Hello friends, Mr. Burrell here. We're in Unit 3. We're talking about parallel lines. Today we're going to be introducing parallel lines and transversals. We're going to be talking about some generic terminology and some unique characteristics and relationships that exist with parallel lines and transversals, and we'll discuss what those are. Okay, so first thing, what is a parallel line? When you think of a parallel line, what is that? A line is considered parallel when two lines never touch, or they're the same distance apart. So two lines that just go on forever, don't cross, never touch each other, those are parallel lines. So like these lines on the football field, lines on a train track, these bars when you're reading sheet music, anything like that would be considered parallel lines. Two lines that never touch, always the same distance apart. Those are parallel lines. A transversal, when we talk about a transversal is a line that cuts through a set of parallel lines. So if you've ever been to like Walmart or one of those big stores like that and you see those diagonal parking stalls, that big line that goes down all the way down the middle of all of those parallel parking stalls, that would be considered a transversal. I have this front gate that's held up by this transversal that's bracing all these parallel lines. I have these arrows in a tree with another arrow cutting through. Those are all transversals, a line that cuts through a set of parallel lines. Now, what is an angle? A lot of times when we think of angles, we think of something like this. This would be an angle. So the definition that we're going to use for this class, for the sake of what we're going to be doing, is an angle is the space between two intersecting lines. It's formed by these two lines right here. And we measure the space in between using degrees. So like this might be a 45-degree angle, a 20-degree angle, 65-degree angle, 145-degree angle, etc., etc. This picture right here, if you can see it, this is like the corner of a soccer field, I think. So this angle right here could be measured in terms of degree. We could actually measure that. This angle right up here with my clock face, I could measure the angle between these different hands on the clock face. All sorts of real-life examples, real-life situations where you see angles being used, and we're going to use them in this unit. Now, you've probably heard this term before, the term congruent. What does congruent mean? Well, congruent means identical, the same size, the same shape, something like that. Two things that are congruent means that they're the same. They're equal to each other. So like these two angles down here are both 48 degrees. They're both the same. So we would call those congruent angles. I have like this Ferris wheel over here, and all these bars, those metal bars are the same distance apart. They're kind of strategically placed like that. Those would be congruent to each other. They're the exact same size. They'd all be this 20-degree angle measure. The sides of this house where it meets with the roof, those form congruent angles because they're identical. They are the same. So congruent just means the same. And specifically when we're talking about angles, we're talking about that the angle measures are the same. They have the exact same angle measure. Okay, what does supplementary mean? I'm going to move this down so you can see down here. But supplementary angles are angles that add up to 180 degrees. So you might think of like if you're on a skateboard or on a snowboard and you go off a jump and you go all the way around, that's 360 degrees. If I start here and I go all the way around, that's 360 degrees. Well, half of that, if I start here and I go half the way around, that's going to be 180 degrees. So two angles that add up to 180 degrees we're going to call supplementary angles. So for example, I have this straight line. It looks kind of like an open book with a page poking out. These two angles, 120 degrees and 60 degrees, they complete this whole line. They add up to 180 degrees, so we're going to call those supplementary angles. These two angles right here would be supplementary angles. That's like the banister on your staircase. These two angles right here are supplementary angles, those angles on the corners of your cabinets. Those would be supplementary angles. So I show you all these examples, all these like kind of real-world examples, because what we're going to be talking about in this unit and then in the next several units, things having to do with lines and shapes, triangles, angles, parallel lines specifically, all these different things, you see them all the time. So these relationships that we talk about are going to come in handy because you'll see them in lots of different real-world situations. So we'll go over some of these as an explanation, and we'll talk about what we call each of these different types of angles. So we talked about angles, we talked about congruent angles, supplementary angles. So what? Why do we talk about those things? Well, with parallel lines, when I have two parallel lines and a transversal that cuts through, there's some very specific types of angle relationships that pop up. We're going to get to that in just a minute. But first of all, we're going to call them certain things. We have specific names for these different types of angles. So, for example, I have these purple parallel lines, two angles that are on the exterior, say one up here and one down here, two angles that are on the exterior of these parallel lines we're going to call exterior angles. Two angles that are, say, on the interior of these parallel lines I'm going to call interior angles. Angles on the outside are exterior, angles on the inside are interior. That's what we're going to call them. Now if I draw this blue transversal cutting through here, angles that are on alternate or opposite sides of the transversal, like these, we're going to call alternate angles. So if I had two angles that were on alternate sides of the transversal, like these, and on the interior of the parallel lines, they would be called alternate interior angles. We'll see that one just in a minute. Say I have two angles that are on the same side or the consecutive side of the transversal, like 4 and 6, I'm going to call those consecutive angles. And since they are also on the interior of the parallel lines, I'm going to call those consecutive interior angles. So we'll get to some of those in a minute. So when two lines are parallel and I cut those parallel lines with a transversal, some very specific angle relationships exist. So I'm going to color in some of these. I'm going to color these angles right here. I'm going to color these red. And let me switch my colors up here. Let me get, say, a green. Oh, whoops. Let me get, say, a green one. This right here. All of these green angles are going to be congruent to each other. All of those green angles are going to be congruent to each other. And all of these red angles are also going to be congruent to each other. So these ones, these ones, these ones, these ones, always the same. No matter what. Whenever I have two parallel lines and I cut it with a transversal, these relationships never change. These four angles, 2, 3, 6, and 7, will always be the same. And these four angles, 1, 4, 5, and 8, will always be the same. Then, when I add a green and a red angle together, they will always add up to 180 degrees, or they will always be supplementary. See where we're going with this? Always. There will be two relationships that will occur with these angles in parallel lines. They will either be, two angles will be congruent, or two angles will be supplementary. So like 5 and 4, and 5 and 1, 5 and 8, those are all congruent to each other. 5 and 6, 5 and 3, 5 and 2, 4 and 7, all those will be supplementary. Every single time. It never changes. That's always the case when you have two parallel lines, a transversal cutting through it, however far apart the parallel lines are, or however the transversal cuts through it, those relationships will always exist. And I think that's pretty cool. I think that's pretty cool. One of the really cool things about math. Okay, so we're going to go through each of these different angle types and we're going to name them. So like these angles right here, we're going to call alternate interior angles because they're on alternate or opposite sides of the transversal and on the interior of the parallel lines. Those angles are congruent. Alternate interior angles are congruent because if you think of these angles that are across from each other, they're all congruent. So these two are going to be congruent or the same measure. Those are alternate interior angles. Alternate exterior, so those are on alternate sides of the transversal, and on the exterior of the parallel lines, those are also going to be congruent. Here were our alternate interior angles, here are alternate exterior angles, they are all congruent, or equal to each other. They all have the same measure. Those are alternate exterior angles. Consecutive interior angles, so if I have this one right here and this one right here, consecutive interior angles are going to be supplementary. Because if you look back at our picture before, maybe these were all my red ones, and then these were my green ones. A red plus a green would be two supplementary angles. So these two, this kind of bigger one and this kind of smaller one, are going to be supplementary angles. And we call those consecutive interior. Corresponding angles are named kind of weird. I'm not sure if I completely agree with the way that they identify these. But basically, if I picked this angle up off of this bottom parallel line, place it in the exact same place on this top parallel line, those are corresponding angles, and they are also congruent. They are the same measure. So those are congruent angles, those corresponding angles. Vertical angles are angles that are directly across from each other, just like that. Those would be vertical angles. These would be vertical angles, and vertical angles are congruent. So in the little X's that you see on these parallel lines, right here, right here, right here, right here, those are vertical angles, and they are congruent. Angles that form a linear pair, or in other words, two angles that form a straight line, if you remember that all the way around a circle would be 360 degrees, halfway across a circle to form a straight line would be 180 degrees. So angles that form a linear pair are supplementary. Angles that form a linear pair are supplementary, or they add up to 180 degrees. And that is all the different kinds of angle pairs that we're going to talk about in this class. So if you want to take a minute, right here on this page, for example, you could identify what some of these different angle pairs are. So like 3 and 7, those would be let's angles, and they would be congruent. Those are corresponding angles, and they are congruent. Let's go to 3 and 5, for example. 3 and 5 are going to be alternate interior angles, and they are also going to be congruent. So in your homework, you might see these different examples. Maybe you'll see two sets of parallel lines. It'll give you these numbers, and you have to say, okay, are these two angles congruent? Are they supplementary? And what do I call them? And you call them by each of these different terms that we've discussed. So I hope that was helpful. We're going to be talking a lot more about parallel lines and how we apply them. So I hope you enjoyed that video as much as I did.